Welcome to another CO2 Monday in the Refrigeration Mentor podcast. Once again, thank you for taking the time to come and hang out with us for an hour, learn a little bit about CO2, some new technology, some new people, and some of the experts in the industry. As always, please share this on different social media platforms. It really helps more people grow their knowledge. This week, we got a great conversation, something that I'm super excited about, something that is very new to me. I met both Larry and Alex at the Atmosphere America Summit, and they were telling me that they have CO2 ice machines. And I'm like, what? CO2 ice machines? Because I'm in the world of commercial CO2 refrigeration and learned about heat pumps. I've heard about water heaters. CO2 is nothing new, but CO2 ice machines is new to me. Larry, Alex, welcome to the Refrigeration Mentor podcast. How you doing?
Good afternoon.
Yep. Hey, Trevor. Thank you.
Thanks for joining. Alex, why don't you do an introduction of yourself?
I'm Alex Pawlikowski. I have been with Howe Corporation for 25 years now. I started as a reception and moved through various departments over the years, from accounting to parts to service, a little bit of purchasing, a little bit of operations, and now I am the head of sales for Howe Corporation.
Awesome. Congratulations.
Thank you.
Larry, how about you?
Okay, sure. I've been in this industry for a long time. Actually, it started out when I was very young. I saw a window air conditioning unit, and one side cold came out, the other side I went outside and looked, and out came warm air. And there's a round black cylinder and motors and pipes, and just curious on how that all worked. So that kind of plagued me through growing up, and I've always been a tinkerer, mechanically inclined guy. That was the seed was planted, Trevor, way back when. Then came school and went to college and started out in electronics, computer engineering, and it just decided, hey, this ain't me. And I met a guy that at Milwaukee School of Engineering, which is close to Johnson Controls, and Johnson Controls heavily influences that school. Well, they had a big refrigeration rig, and always curious, where do these pipes go? How does this work? Make no sense to me. And I met a guy that was in the program there. His dad had a business, and on the weekend, I ran a truck with him. And I found my passion. I have motors, I have electrical stuff and wires and pipes and things that get hot, things that get cold. And the curiosity is still, how does this work? So I researched it, and then, it was just a fantastic start. I went then to a community college and got my Associate's of Applied Science degree. And I taught at the college while I worked and while I got my degree there. Then I went to work in the field, in the service world. I did mostly commercial work and rooftops and big chillers, apartment buildings, air conditioning units, you name it. I was just growing crazily with that stuff. And I could climb a vertical ladder with a 30-pound cylinder in one hand and a tool belt. Just climb, get up to the roof hatch, get out there.
We were so safe back then.
So yeah, and then I was approached by Parker Hannifin Corporation. They had just opened up a research and development lab in Wheeling for their controls, and they wanted someone to come in and work the lab. So I was like, that was another turning point, another knock on the door. And so I answered, and that started my inside career. Nothing breaks when it's really nice out, right, Trevor? It's either hot or cold. I made the decision to go into the R&D lab, and it's just another serendipitous moment where I got to work with the captains of the industry in Unveil. So Controls Company of America, Eaton, Singer, these engineers were my mentors. I ran the lab there, did a lot of experience, learned, study, learn, ask a lot of questions to these guys. And I developed then a pretty strong career in the control segment. So I couldn't advance any further. It's a matrix organization. And they said, we know you can do more, but you need a degree. So I went back to school. I worked there part-time while I was in school. You got to pay the bills and maintain the relationship. And I ended up getting my bachelor's degree in mechanical engineering and went back to work for Parker. We moved the facility down to the TXC facility in Florida. So I went down and worked the lab there, worked with the director of engineering, who was actually the director of engineering. He came from Valve, which is a big solenoid manufacturer. Again, serendipitously able to just absorb a ton of information from these guys. And I just learned more and more there. Got in, we were in the automotive industry, got into electric valves. Then I became this electric valve expert working in that segment. Things happened. I moved back up here and went to work with refrigerating specialties. That's ammonia systems. Worked at Hansen Technologies, again, a larger industrial ammonia systems. And then I moved from the component side, designing valves and accessories, over to machine side. So I joined a chiller company, and now I got another chance to grow and learn in a different area. So instead of just the components, now I'm doing refrigeration assemblies. Spent a lot of times in the chiller industry, special applications, design outdoor systems, indoor systems, special systems, handled exotic fluid like Florner, which is a high dielectric, but has this weird density property. So it's just very difficult to deal with. Fantastic opportunity, more learning. Got in semiconductor industry a little bit there, MRIs, backing all that up. So I had a lot of application and experience under my belt there. Moved to another manufacturer on chillers, big industrial stuff. Worked with turbo core oilless compressors, designed one of the first ice rink chiller type with a turbo core 2-stage. Really loved working with that. Had a great crew there, really fantastic programming guys. Designed a lot in variable speed, which is a whole nother animal, and it's coming back a lot in the CO2 realm with the variable speed compressors. And I got to work with a vibration expert. I worked with vibration people out of Copeland compressor. So I learned a lot about vibrations. It's a big issue with variable speed. Mastered that. Moved on then to making ice. And now I'm at Howe Corporation, and we're going to drive this corporation into tomorrow. I mean, we're already been there, but we're going to continue to innovate, grow, and learn.
I love that. And everyone, if you just listen to the quick story of Larry, it was all about growing and continuing to grow and challenging himself and moving it. Because this is new to me. I haven't heard his story about before, but stepping up to the plate, get to the point where you feel like, okay, I'm maxed out now. Now let's go on and invest in myself more, grow. And this is what refrigeration is all about. The sky is not even the limit. You can keep going. I love it. Well, thank you very much for the introduction. So we're going to be diving into some of your ice machines. And I know you sent me a couple of the instruction manuals. I haven't seen them before. They're nicely laid out. I appreciate that because it makes it easier for technical people in the field to look at that. Why don't you talk about a few pieces of equipment that you do offer? Because the one that you sent me is the Rapid Ice Flaker. You got multiple models for the CO2. And then you were telling me you got split systems and non-split systems. I'm so excited to start to learn more about some of the stuff.
We do. Howe Corporation makes flake ice machines that range from 1,000 through 20,000 pounds of daily production. Our smaller machines are used at the supermarkets, and our larger machines from about 6,000 pounds up are used in various industrial applications, such as seafood processors. Our units can be found from sea to plate, from fishing vessels to processors, wholesalers, transportation, all the way to the supermarkets. In bakeries and sausages, our ice is used as an ingredient. It is mixed with the product to remove the heat from the product and to keep it cold. Produce industry uses our ice from farm to table. Poultry uses our ice. And then there's fun applications such as zoos and aquariums. They'll put our machine up over a penguin exhibit and it's literally snowing on them. So we have some very fun applications, but the units are available in various refrigerant configurations, from R744 CO2 for liquid overfeed, as well as direct expansion, to ammonia units for high pressure systems and recirculated systems, to 448, 449, the standard synthetic refrigerants. Our smallest unit is available in self-contained. Most of the 1,000 pound machine is available in self-contained configuration from 2,000 through 20,000. is either central system connected or split systems.
Wow. So is that like a day, an hour? Like how many is that? 1,000 pounds a day? 1,000 pounds?
That's 1,000 pounds per day, about 46 pounds per hour.
Oh, that's a lot of
It's a lot of ice.
that's a lot of ice.
Yeah, because the largest machine makes 833 pounds per ice in an hour.
Wow. Okay, that's definitely impressive. So so you guys have been making ice machines and flakers for a long time. When did the idea of coming up with let's make a CO2 ice flaker? When did that happen? And how did that even happen?
Working with various supermarkets. It was in 2009 that we built and shipped our first CO2 2,000-pound ice machine. We were working at that time with Shaw's Markets up in Massachusetts, and they were putting in a liquid overfeed system. They have been using our machines for the regular synthetic CO2. Synthetic refrigerants, but they were putting in a CO2 system, and they reached out to see if we would design something. So at that point, our engineers started working with Hill Phoenix. We designed a machine, we tested it in Conyers, Georgia with their rack system.
Awesome. So this is actually connected directly to the rack, so it's not standalone.
That is correct. The first generation of Howe CO2 flakers were the liquid overfeed machines. We have 4 different models: 1,000, 2,000, 4,000, and 6,000 pound machine. And then I want to say early 2000 teens is when we built our first direct expansion machine. And those are available in 3 models: 1,000, 2,000, and 4,000 pound machines. So these are basically used at various supermarkets.
Cool. Yeah. You got liquid overfeed and you got direct expansion. You want to kind of do a quick explanation on why would you pick one or the other? Like, why would I pick an overfeed over a direct expansion?
As CO2 evolved in the supermarket industry, it wasn't the first secondary coolant. So in Cascade Systems started with glycol, and they would pump the glycol through, chill it, and pump the glycol to the cases and the loads. And so that was really the first like overfeed type system out there. And in fact, when I was at Parker Hannifin, we had a lot of fun dealing with solenoid valves. They're pilot operated and trying to get the glycol through a pilot hole, like pushing gummy bears through there. We did master that, but that's where liquid overfeed or recirculated systems started. And then it evolved over to the Cascade CO2. CO2, much easier to pump than glycol. It's safe. And so actually it was ammonia Cascade CO2s on the recirculated pump systems. And neat thing about this industry is it's constant innovation right now, and growth and change and development. See that happening, all these new innovations and transcritical that's happening out there. Eventually the industry moved away from the overfeed recirculated systems, and now it's dominated by the direct expansion. However, there's still quite a few recirculated CO2 secondary systems out there. So the majority of what we're seeing now would be the DX. You have your charge is a lot lower. You don't need the full receiver full on your recirc, and you don't have the waste to pump energy with the DX. That's really seems to be the direction it's going. And the ammonia Cascade system kind of fell a little bit in disfavor. Ammonia, not a normally seen refrigerant by service crews, and then of course the environmental potential that could occur in a commercial space wasn't really welcomed, and so DX took over.
Yeah. And we're going to see a mix of that, I believe. Like we're going to see over the next 10 years, lots of secondary systems being installed as well as transcritical systems. Just because what I'm seeing when I'm talking to different end users is like the switch from what they have now to go straight to transcritical could be too much of disruption for the store compared to secondary. So I think you're going to see still some play with those liquid overfeed systems as well.
Yeah, that'd be great. Yeah, this is just kind of diagram showing the difference between the two. So on the left side, you can see it's a little bit simpler. Liquid comes in the bottom, you have a strainer, solenoid valve, and then you have your metering valve, and then just a stop valve on the outlet. Of course, with any CO2, you need a clear view back to a relief valve. So on the top, because the solenoid could shut, the valve on the bottom could be shut. You could end up trapping. We always check around any sort of stop valve so we have a clear sight of a relief. That's what the little check on the top is. On the right side is a kind of a schematic of the DX system. Number one is the solenoid valve. So that's the liquid coming in. It feeds number two, which is the EEV, enters the evaporator. We make ice. We have pressure sensor number 4 on the outlet. And we come up to number 5, which is a EEPR. So we regulate the pressure. And then number 6, notice the 2 relief valves. So in between the check and the EEV, there's a potential to trap. So we relieve back to a clear sight to the receiver flash tank relief valve. Similarly on the other line.
The liquid overfeed, you guys, that's what you first started with 20 years ago, probably close to that when you started developing that. The direct expansion, probably the last 10 years. How long ago have you been at last 10 years?
Yeah, that sounds about right.
Yeah. And so now with this design here, I see you have these check valves. Is this system designed for like standstill pressure? I see that you have reliefs there, but just say the power goes out into the building, is it designed to be able to handle those standstill pressures?
So right now, this one is, the picture you see there is actually a 45 bar, so like 653. Well, we're actually, Trevor, we're seeing a push now from the customer base. So typically they would have like a HFC backup condensing unit to maintain the flash tank pressure. And then they would have a generator for that. And so they're deciding there's a cost ramification for that. There's a maintenance, and it's not 100% green. The standstill pressures now are going up, and we're seeing a request for 80 bar plus withstand capability. So that's something that's in the future here. We're going to check. So we'll put a check in the suction line, and we've got withstand capability on the liquid line, and then we'll put a safety relief on the vessel. So we're good to 80 bar. Actually envisioning a new generation that'll be 140 bar withstand. That's a little ways down the road yet, but yeah, it's coming. And that's one of the advantages of the Howe evaporators. We're all steel and we're all welded. We have the ability to withstand some of these high standstills.
Yeah, that's the one thing. It's not a big deal that it is now or not, because the rest of the system still has to grow up. All the other evaporators would have to be able to last that standstill pressure anyway. So it's whatever the lowest pressure can handle. But I just wanted to ask that because this is continuing what I'm hearing too, is like we'd like to be able to shut it off and not have to worry about any of the reliefs going in. And we're going to get to that point. It might be 5, 10, 15 years, but you guys are already on your way. You guys are already on your way.
Yep. You know, we have to be sanitary certified and safety certified to UL, and they have a 5-time pressure rating. And we've actually put one of our vessels through there without an issue. 5 times over, we're golden.
Yeah. Yeah, no, that's perfect. And this is what's great about doing these certifications, is because lots of people say, oh, it's just a pain. It doesn't have to be that high, but you did it. You've done it. It's passed. And you're ready to go. You can really ship it almost anywhere in the world with passing those ratings, because they're some of the strictest.
Yep.
Awesome. I'd love to hear some more about some of these, this direct expansion system. So you have the direct expansion in supermarket applications at this point, going from 1,000 pounds a day up to 6,000 pounds a day. Okay, here's a slide of some of your customers.
Yeah, majority of our CO2 flaker customers are still supermarkets. We're currently working on a couple industrial projects. And the biggest reason why it's our biggest customer base has been supermarkets is up until recently, there really hasn't been a low temp CO2 condensing unit. And with the supermarket install, you connect it to a central rack system. And for the industrial install, typically our machines would be connected to a dedicated condensing unit. But until one is available, there was no way for us to be able to work with industrial customers, although many of our customers that are switching from your traditional synthetic refrigerants, 404s and 507, have been asking for a larger capacity CO2 flaker.
Nice. So I'm sure that's been being tested and it's in the works, and because there's a lot of new technologies coming out, because I see multi-stage compressors like Dorin has one. Toshiba wouldn't be big enough. There's screw compressors coming out with economizers. There's transcritical scroll. So there's lots of different potentials out there.
Yep.
Awesome. Okay.
So we wanted to talk a little bit about the design of our machine before we take you out to the lab.
Oh, I'm excited about that.
Yeah, so the best thing about the HOWE machine is its simple elegance in the design. You'll see it when it runs, etc. We'll start down here at the bottom right. There's a water reservoir and pump system. The water enters, float valve maintains the level, and the pump pumps the water up that black tube on the right-hand side, and it pours it into a distribution tray in the center just under the top crown part. And off of that distribution, there's little pipes that come off and approach the edge. So the blue stripe that you see in the cutaway is the actual evaporator surface. The orange is insulation. And the center part, there's a shaft and a scraper. Also, just immediate to the right of the serrated scraper is a squeegee. So we actually wipe the surface of the ice to conserve water. That's a wonderful feature about the HOWE ice is it's dry. We dry it before we crack it off of the evaporator surface. So here's actual video of it running. Here comes the squeegee. It dries the ice. Here comes the scraper, cracks it off the surface. Now comes the water feed tubes from the distribution pan, and it refreezes on the surface. This isn't a batch machine, it's a continuous operated machine. Unlike some of the machines out there that have to go through a harvest cycle and a dump, a reservoir dump, we don't do that. This is just continuous ice production. So you see the reservoir on the top and the tubes wash the evaporator surface. And the thing to notice there is that nice milky color. Then you know you're set correctly. That's one of the beauties of the HOWE design too, and its elegance. And first thing you do is you set your evaporator pressure on CO2. It's really easy with the EEPR and our control system. And then after you establish your saturated suction temperature and you know your evaporator wall, then the next thing you do is do your superheat. And again, it's an EEV on that, so it becomes very easy not only to adjust, but to maintain. And we'll show some of that. We'll show the valving in a little bit.
I thought that was pretty cool. Thanks, Alex, for showing that video on how that actually works, because I haven't seen inside of that design before. It's real cool. So anybody who's listening on the podcast, definitely check out the video that Alex just showed, because it's cool where you just put the water on there, it freezes instantly, and then you just scrape it. Well, you squeegee it, water it, scrape it, and it just continues to happen, and you get piles and piles of ice.
Yeah, so by squeegeeing it, you're actually removing any excess water that is then being returned to the trough. So you're conserving any unused water, and you're reusing that same water, which makes the machine the most energy efficient machine, true flake ice machine out there.
Awesome.
Yeah, a green machine too. You know, we keep the water, don't put it down the drain.
And that's the best way to do it, because water in certain places are very, here in Canada, there's lots of water, but there's lots of parts of the world where water is hard to come by, right?
Well, like Australia, they have, watermark standard with a lot of regulations on usage and sanitation, because it's a little harder there, even though they're in the middle of the lake.
So that's pretty neat how that works. And so this design that you're showing here has a pump on the top, and you get your auger and stuff. I don't know, you don't call it an auger. What do you call it? It's just a scraper?
It's an auger, it's a shaft.
Shaft auger. And so they would just get bigger in size for the bigger machines. Is that correct? Or are they different
Pretty much.
designs? Okay.
Yeah, so they'll grow in diameter and in height.
Okay. It'd have to be pretty big for 800 pounds an hour.
Yep.
Man, that's pretty intense. These here, would these be installed by a contractor? I guess a hiring contractor. So the contractor would get this piece of equipment. Would it go on top, usually a walk-in box, and like in a supermarket? How does it really work when you're working with the supermarket customers?
So in the supermarket, it's installed on top of a storage bin, whether it's one of those type of storage bins where you have rolling carts underneath for they're less labor intensive, or just a standard, they call them ice box type of storage bins that has a big door in the middle and someone scoops the ice out of it. That's in the supermarket industry. In the food process industry, correct, it'll either sit on top of a walk-in, or seafood processors will put it on a platform with their fish vats that they use, and they're just reusing them for ice. And they'll put 2, 4, 6, however many they need, directly beneath the platform where the ice machine is sitting on, and it just keeps making ice.
Yeah. It just keeps going and going. So this would be connected directly to a rack. So I'm assuming you would just have off the rack, it would be a circuit. So you'd have a liquid line leaving the rack. That would be your liquid circuit. Then you'd have a suction coming back. Would that basically how it would come off a rack?
Yeah,
That's it.
exactly. Sometimes the rack will have an EPR too, but you can either blow that open or you can run their EPR and bypass ours.
Interesting. Yeah. So you just set it up off the control or whatever it is.
Yeah, and the way that these machines are designed is, as long as this machine gets a consistent quality and quantity refrigerant, it's an open style evaporator, right? So it requires very little maintenance. There's only one moving part, which is that main shaft. If they grease it twice a year, once a year, and continue with the good PM, the units will last them forever. And I kid you not, there's machines out there that we've built in 80s and 90s that are still working great, and customers are happy. Sometimes they'll call for parts, but very happy.
Yeah. So do you have to, because I see you got a water vat there where the water's being pumped in. So I'm assuming, do you have filters and options for the customers? Like if you got super hard water, soft water for scaling, things like that?
We do offer water filter systems. There's size per various size of the machines. We offer 3 different water filter systems, but many times too, especially in the supermarket industry, they already have the filter system that filters the entire store. So as long as that water is somewhat filtered, they don't need an additional water filter for the flaker itself.
Because I know on all the ice machines I've worked on, because I haven't worked on like this design, honestly, is that there's a lot of cleaning. They scale up a lot, they get really dirty, they get moldy. And I just kind of want to get an idea of what's the process. I'm assuming there's certain cleaning products and maintenance that are probably pretty important to do for these equipment. And I did see some of it in your manual. What are some tips or tricks, Larry, that you could give for someone who is going to do a maintenance on this unit?
Yeah, you're right, Trevor. The water's probably the number one issue with these. The rest of the machine is rock solid, and maintenance, unfortunately, falls off of most people's radar. We're set up nicely for that. It's pretty simple, like in the water reservoir. You can just add the cleaner right there, and we'll see a little bit later. I'll show you we have a main control, and you can set the timer up, and you start it, and it'll just circulate through the system, and you see the little tubes going around will wash the surface. And then there's also a drain valve on the reservoir. You drain it out, flush it, and you're golden.
Awesome.
Yeah, so it's pretty easy. This machine's a technician's best friend.
Yeah, it's just doing it, right? Doing them like you said, just getting the maintenance done. That is awesome. Do you have anything else you want to share on this slide, Alex or Larry?
No, as far as the slides are concerned, we're done with slides. So now Larry will take you to the lab.
And we'll see it. We're going to look at an actual machine running. I can show you some of that, and then I'll do a quick review of our controls, the EEV and the EPR. We use Kelvin controls. They've been around a long time, but I'm kind of a fan of those.
Well, since you worked on them forever, even before Howe, so that's perfect.
Right.
You got the expert there using it.
Yep. They've grown up over the years too, but we'll take a look at that. So I'm going to go offline here for a second. I'll be back shortly.
Yeah, awesome. So Alex, so you've been with the company for quite a long time. What are some of the things that you've seen evolve over the last, say, 10 years? So you've been doing CO2. How do you see that transition? Because I know you still have a lot of synthetics. You're still probably selling way more synthetics than CO2. What is that transition starting to look like for you over the last couple of years?
It's transitioning into CO2, but it's also transitioning from 404s, 507s, 404s to the lower GWP refrigerants, the 448s, 449s. I know that up in Canada, 404 is, especially on the new project, they can no longer use 404. So our machines are available in 448, 449 from the 1,000 all the way up to the 20,000 pound machine. California is the same way too. Like California's pretty much started that process too in the United States, and other states started following. So there's definitely more 448, 449 applications. They're even getting away from 407 A, C, F, with various 407s and moving towards the 448s, 449s.
Have you guys been testing any, and I'm assuming you have, is any of the A2Ls, these low GWP refrigerants or lower GWP refrigerants yet?
Larry's been looking into that.
Okay. Because that's the thing, over the last 7-8 years, there are so many different refrigerant out there and you can't test them all. You just,
No, you can't.
you can't test them all because there's just too many of them. And I think this is something that's been difficult for different manufacturers, different contractors out there, is the plethora of different refrigerants. And it's going to get, soon we'll get to a point where just there's only going to be a few again. But right at this point, there is a lot out there. What is two of the coolest things you like about the CO2 ice flaker versus the other refrigerants?
So on our side, it really doesn't make that much of a difference. I know that it's for contractors, it's easier to, because the way that our machines are, like Larry explained, like once you set the pressures and you set your EEV and you set your EEPR and the machine is getting consistent quality refrigerant, the evaporator itself is, for the most part, is all the same, just getting various refrigerants that it's getting.
Awesome. Alex, you want to stop sharing for a second and we'll pop Larry's screen up here for everyone. So Larry, this is in the lab. So right now is kind of the image of the video you showed earlier. So you get your water going into, I guess it's like a star. What would you call that?
We call it the water distribution pan.
Yeah. And then now it's spreading out over the cool plate, so evaporating plate. And then behind that you have the scraper and then the sweeper.
Right. So the evaporator itself, the temperature of the evap is at -5 Fahrenheit. So once that water touches that wall, it automatically freezes. That squeegee removes any extra water, making the ice coming out subcooled. The temperature of the ice produced is actually 22°F versus the typical ice machine that's 32°F.
Wow. Okay, so I said it wrong. So it's water,
Yeah.
squeegee, and then scraper.
And then scraper. Yeah.
Yeah, a thing here to notice, you can see the wall, how spotty it is. It's because I just started up, and so we're going to have a warm situation. We're going to have high superheat. So for a service technician, if you're to come and then get a complaint, I'm not getting a lot of ice, and you see this type of wall condition, you say, oh, now I know what to do. So you would check the superheat and the pressure. So you can see it's starting to develop that milky film across the whole surface. That is the correct, like we saw in the other video. Then you know your pressure's correct and your superheat's good. So this is kind of nice. It shows what a bad behaving evaporator would look like. But this is just on startup.
Yeah, and well, because your superheat's really high, you don't have that cool gas. It's not as cold, not enough refrigerant there yet. But as it gets milky white, then you have enough. It looks like it's getting better and better every pass.
Yeah.
Awesome. That's super cool. And basically straightforward, this is it. This is a CO2 ice flaker.
Yes.
I love it. And so what do you find, Larry? You do a lot of the support calls for technicians in the field and customers. What do you find are like some of the top areas where you get the calls, like some of the troubleshooting things? Like what are, say, one or two of the top calls that you would get on this ice flaker or any of your ice flakers?
Yeah, we do have a service department. Talk to them. There's very little issues that we've had. They're pretty stable. Occasionally, we measure superheat for the electronic control. So there's a negative temperature coefficient temperature sensor and a pressure transducer that feed the control. Occasionally, we'll see an issue with those. Historically, the valves that have been, pretty rock solid. Occasionally, you'll get a valve that sticks, or a winding in the motor will open, but really not much on the refrigeration side. Occasionally, they may have to adjust the superheat or the pressure. So one thing we talk about, we call it good to go. So it'll come out of the factory preset at what we have determined to be like the most nominal setting. Then when you see a situation like this with the zebra stripes on the bottom, tell you, well, even though I'm at the right superheat, I'm not really filling that wall appropriately. Then you would adjust your superheat setting down or up to create that complete milky surface. You could be at 8 degrees, you could be at 2 degrees. We don't really measure or want you to measure superheat, but rather adjust it to get the optimum quality and performance of ice.
Yeah, and that makes sense because different systems are going to have different superheat. And this is what I try to talk to a lot of people. You could have three cases together, but you don't set them all up the same. One could be different than the other. It depends on how it's piped and things like that. Where this here is, I like what you say. It could be 8 degrees super, it could be 2 degrees super to get exactly the right ice. Because making ice is an art.
Also, where we come off the liquid header, right? So if the case is in defrost and it's bring it back down to liquid header, we can have an issue there, or
Yeah.
So you're right. It's situational.
Yeah, no, I love that. So, and what else can you talk about? You said that you wanted to show the electronic valve controller. Be great to see some of that and let everyone kind of
Yeah.
get a firsthand look at
Maybe
it.
Alex can come and join me.
Yep, I'll be right there. So now I'm going to go off for a little bit.
Okay.
So, and then also in the chat, Andrew says how also presets the EPR and the EEV controllers before it leaves the factory. And so this is something that you want to do and you work with your manufacturer with. This is key to get a good understanding of that system. And I really like that you got the electronic valve and you got the EPR. And these are things that you're going to want to learn and study a little bit. So he talked about the Sporlan Calvin controller. I've used it before, seen it. It's a real nice controller. It's been out forever, 10 plus years for sure. And it's just a solid controller. I'm sure they've been advancing the software over the years. They have been actually. And then electronic valves. Sporlan here in North America have been huge on electronic valves for decades. And so they're easy to get at suppliers around here. So the biggest thing is to understand this unit is understand the components that are inside it.
Correct. And like you always said, first thing is to understand, how it works. Look at the wiring diagrams, piping diagrams.
Yeah, it's a great setup you got there, Larry. So you got a superheat controller there, I see. Then you got
So we have superheat and pressure. Like I said, that's the beauty of this system. We set a pressure, and it's very simple, and we program it before it goes, and then it'll read out what the actual pressure is. The transducer is already mounted on the system, so you just connect the wires on this, and then you set a superheat. And if there's an issue, you get the -AL dash. So if that's superheat, we would change that. You can also read parameters through Kelvin, give you your saturation temperature, suction pressure I can read here. So you can do all your diagnostics. You don't need to throw your gauges on there. It's already here for the technician. It's really a nice setup for a technician. So yeah, so you set your pressure, super, you check your ice. If it's not quite right, you're seeing a zebra stripe, you just lower it down a little bit. That's the elegance of this. And everything comes preset, ready to go.
That's one of the big things, like you said, don't have to go and start putting gauges on and things like that yet at this point. Go and look at the controllers, check the controllers out. Unless you assume, think that the pressure transducer is reading off, but the least amount of time you can put gauges on a system, the better for the system itself in general.
Right, exactly. And also the controllers do have manual control. One of the things you can do is go into manual mode and then stroke the valves and make sure they operate. So, so where's the breakdown? Is it electrical? Where is it falling? Is it a mechanical fault in the valve? Is it one of the wiring? Is it a loose wire? So you'll get an open sensor, I'll show you. If the temperature sensor opens, you'll get like a -60. Of course, it didn't do it.
But yeah, no, exactly. These are the things that you need to check. And this goes back to the Sporlan manual, right? And you get the resistance in there. You find out if it's a 2 or a 5 or a 10K, whatever it is. And then you match that temperature up to the resistance chart to what your meter is actually reading it. This is super important to do in the field. These little checks, because I've seen it before with just a loose wire. It wasn't fully out, so it'd work a little bit and didn't work a little bit, and then it would throw you in a loop, but really it was just tightening up those.
Yeah, so it's loose there. So yeah, vibrations. And So same thing with the pressure transducer. It should give us an alarm on that. But then, if you're open circuit or not. Yeah, there, the ALs. And then also AL on the superheat because the pressure, it all feeds both controllers. That's what one pressure transducer, both controllers. So if you see your double ALs, then you're pretty sure that you're got an issue with the pressure transducer. If this pressure reads correctly and you got an AL on superheat, then I would head for my temperature sensor and look at that.
That's a great tip.
Then you can go to manual mode and stroke the valves. One nice thing about the valves is when they stroke, they overstroke so they know where they're at. So as the valve moves over time, it's going to lose its position. So you always have friction, stiction, and hysteresis. So that valve's never going to always be in the same spot. So nice thing what Splone does, they overdrive the number of steps to guarantee they're on the seat, and then they know where their 0 point is, and then they open and begin to control. So you can actually use your hands, which is a great tool that I learned over the years. You're like a doctor, your gauges are a stethoscope, but your hands got to touch the patient, hot, cold, and vibration. So you can grab the motor, stroke the valve all the way down, or do a power cycle where it does the overdrive, and you'll feel it clutch. Then you can say, oh, so the motor's good. There's some other problem happening.
Yeah, that's another great tip because you want to know if it's moving. That's a big thing. I've seen so many electronic valves replaced over the years, and it wasn't the valve itself. It was a parameter, it was a wire, it was a transducer. And that's something that you just want to be aware of.
Yeah. And Trevor, it's always the expansion valve, right?
Yeah, no, 100%. Yeah, 100%.
Another option is to use a SMA 12. So that's a tool that's readily available. I put a pigtail of an M12 because all of our valves will have M12.
Yep.
And you can actually stroke the valve electrically with the SMA 12 to verify operation.
Yeah, and that's key. I talk in all my supermarket programs and CO2 programs, like you need the proper tools to do your job. And like lots of people, SMA 12 is so expensive. It's part of your tools, right?
Yeah, exactly. Troubleshooting so easy on these electric valves. Again, you can feel it and see if it clutches. Oh, it's clutching, so I know I'm good. Another neat thing is say you have one of the windings is open, it's the bipolar, so you got two sets of windings, black, white, red, and green. Now notice that the outside, the black and white, are not pulsing. So that's telling me I've got an open winding or a bad wire in there. So that's the SMA 12 can also give you a little bit more diagnostics that way. And if you just have the valve, someone else is using a different controller, they don't want to use Kelvin, they're using a Corral or Danfoss or somebody else's to drive the valve, you can always take the leads off and put them onto the SMA 12 too. Just like instead of having a whip, you can connect the valve right up and check it that way too. The valve stroke, they come in the other controllers. That's the other thing. We haven't married ourselves into anybody's controller. We're kind of like an open source. If you want to use a different manufacturer's control, we give that openness to it. We prefer this because we can guarantee performance and operation with this, but we didn't dedicate ourselves to an Emerson controller or a Danfoss.
Yeah, no, that's good. And that's important to some customers because they want you to be able to be flexible and jump over through hoops sometimes.
Yeah, the other is the controllers. This box is the RLE. So our RLE, the E is enclosed. So this box would be mounted inside the enclosure and handled. This is all you have. Would control everything. There would be a Kelvin controller on the side, but this does the other function. Like I mentioned, the delay timer, you would go up to 30 minutes if you're going to do that clean cycle, do the cycle, and then cycle, it would run the motor on the top for that 30 minutes to circulate the cleaner. The other neat thing we do is we measure the motor current to the drive motor on the top. If it was misadjusted or a problem happened and the ice built up too and stuck the scraper to the wall, we would sense the current and we would shut the system down, have an adjustable current for the different motor horsepowers. So very simple. Then the light comes on and you've got an issue and you check what happened. Maybe the pressure went low, the valve stuck. And then we have actually bin eyes that would shut the system down too. So it's photo eyes, and then it would pump the system down at that point, open the solenoid, and go into next ready mode until the eyes were cleared.
And so what's the eye taking a look at there, that sensing eye? What's it looking at?
Oh, it goes across the bottom of the flaker.
Okay.
So where the ice drops out the bottom, as it starts to fill up, it would break the beam on the eyes and say, "Oh, I'm full," and turn the machine off.
Yeah, perfect. Yeah, no, that makes total sense.
And then the regular RLs, you would get this box to mount, and essentially the same controller here, the eyes, power relays. So pretty straightforward, pretty simple for technician to install and troubleshoot.
Yeah, well, it's pretty. You got a contactor, transformer, pretty, yeah, and it's nicely laid out. It looks really, really clean. Whoever's listening on the podcast, definitely come and check this video out. There's a lot of cool features, and it's straightforward, and that's what technicians are looking for: stuff straightforward to work on. And then customers are just looking for reliable. If the big thing is the maintenance for the customer, we got to get the customers to continue to get those maintenances, because that, I think that's the most important part. We
Right.
talk about all
Yep.
do a lot of talk about equipment, and then if the customer doesn't do maintenances, could run into issues.
Yep. How about a quick glimpse of the future?
I'd love it. I'd love
All
it.
right. We have our CO2 flaker here, EEPR, EEV. Here's our check lines. So we've got a clear sight to a relief valve, a water pump, and a dry motor. So that's pretty straightforward. And we pipe this over to our future offering here it's a Rivicold CN CO2 condensing unit. So this
Cool.
gives us the ability to service the clients that need the ice, want CO2, but don't want to put it on rack or don't have a rack available. This is great. This is actually UL approved in the United States. There's a lot of these condensed units starting to come out, but most of the stuff is driven out of Europe. They're not UL approved, so we have problems getting them into our jurisdiction. That's the beauty of Rivicold. They came in, they got it UL approved, and it's really a nice machine. It's one of my favorites that are out there. And we'll take a peek inside. So actually they separated the cabinet from the fan side so you can get in here and actually do troubleshooting. There's the gas cooler, two variable speed fans, and you had the rotary compressors on there previously from Corel. Yeah, and we used the HECU system by Corel. I really am kind of a fan of Corel as well. I've worked with them a very long time, very early on. Great support in the area, and they're innovators. They keep moving it forward. So HECU is great. We got two rotaries. We got a low temp rotary compressor, variable speed. We have the variable speed drives, and actually this feeds an interstage cooler, right? So you de-superheat your discharge gas, but there's two coils in the gas cooler. So actually run a small section through the bottom and de-superheat. That way we're not using a brazed plate, we're not putting the heat back in and letting the parallel compressor deal with it. So we dump it out into the atmosphere where it's unobjectionable, and then it goes into they call it parallel.
Yep.
To me, it's a parallel booster because this feeds directly to the gas cooler. There's no medium temp compressors. It is a parallel in that it's not really doing any work. It maintains the receiver pressure, which is wonderful. And that's the other thing is we don't have a flash gas bypass valve, a receiver pressure regulator. You vary the speed between the two compressors to maintain the receiver pressure. It's awesome. So we save a valve there, which is really neat and a great solution too. The other thing we took, there was a discussion, you can open up the expansion valve to start these. Well, these can't start against the load. So they're direct suction compressors and there's discharge checks, so you can't start them. So what we do have is bypass solenoid valve. So we take the suction gas and bypass it to the discharge, so it's equalized across the compressor. Now the compressor can start. So both compressors come with equalizing valves. That way we're not opening up the expansion valve, potentially get slugged back. Really nice feature, and HECU manages that for us. No crankcase heaters, so these drives are DC. We'll run a little trickle current through the coils and heat them up enough to keep them dry. So we don't need an extra crankcase heater on these machines. It's beautiful. We also have a unique oil return system. They did a lot of work on that. So we pulse the solenoid during what we call an oil boost scenario. where we momentarily increase velocities based off of probably runtime there. And then we pulse the solenoid, which pulls liquid between the two stages and return it back to the sump on the low temp guide. That way we keep even flow of oil, because it's discharging into high or to parallel, and we dump parallel oil back through another solenoid. Another great feature, so we don't need an oil separator on this. It's all managed. Yeah, they did a really nice job on this unit. We're in the process of getting this hooked up and validated. That's the other thing, nice thing about the Kelvin is it's full PID control. So you have proportional, integral, and derivative capabilities. Depending on how stable your receiver pressure is on the CO2 could affect that. Now, with the ability to hit the PI and D terms, we can tune it to overcome some of those oscillations you'll see in the receiver pressure. So if our parallel compressor is having issues, we can tune it out with our controller. The other thing is, if this is capable, we're going to save another valve. We'll take our EEPR off, and we'll just manage with parallel running our flash tank receiver pressure. That's going to be part of our development. Another neat thing they've done for service guys is you can go into HICU and go into vacuum mode, and they energize all the solenoids, the condenser valve or high pressure valve. They open all the valves for you electronically, so you don't have to get in there with your magnet and open the solenoids and put the coils on. Really a nice feature. It's well thought out. This is where we're going. We're looking to get, remote condenser offering into the market for our ice flakers.
That is awesome. I'm super excited for you guys to do this, because I know this is going to go really well. Just want to take me back over to your ice flaker for a second, so we can look at the ice flaker, the one behind you, the one you want to connect to. Yeah. What I like about this is, like, you can work on this very simply. There is like a lot of space. Like, I was thinking when I was first seeing it, was going to be super tight. The valves are not going to be able to, if you ever had to replace one or change anything, it would be real tight. But there's a lot of space here to work on this equipment.
Yeah, wide open. Like I said, it's elegantly simple, but
yeah, no, that's fantastic.
Any problem with the drive and the motor, it's all accessible. All your valves are right here. It's really sweet.
Yeah, it looks amazing. Any final thoughts, Larry? You want to, or Alex, if you're there, any final thoughts for customers or technicians in the field?
Yeah, thing to do would be know that there's no neutral. It's either forward or reverse. So keep yourself on the forward path, push yourself, learn, get over your skis, get uncomfortable every now and then. You might fall, but you can get back up. If you don't, you're going backwards. The world's dynamic. This industry's dynamic. And this isn't a job. This is a career. Get in it. Find that passion. I love it.
Yeah, man, this was awesome. I'd love this session. Anybody, get to the video on YouTube and check out this video if you're listening to it on the podcast, for sure, because there's so many cool things that Larry and Alex just showed us. And I really appreciate you guys taking the time to do this. How can people get a hold of you, Larry, Alex, or Howe Corporation? I want to find out more, because this is super cool. I like the future that you're going to, because I think there's a lot of people that are going to be very interested in that your full CO2 solution, or your green solution, right? Even with your water, making sure you're conserving water. I think that is so important.
Yep. Actually, looking at a large capacity Doran, they've got a great CO2 pump. They pulled the discharge off of the heads, and they just got a huge opening on their compressor envelope. So like you said, there's a lot of possibility there, innovations coming, and that can get us up into a single compressor, high capacity.
Awesome. Yeah, I'm excited for that as well. So here's the information. Larry Rich, his number's there. I'll put this stuff all in the show notes. Anybody who's watching right now, you can take it down. But I want to thank you very much. Alex, any final words?
She's muted. She can't hear.
Okay. Larry, I want to thank you so much for taking the time to show us this really cool product. I'm excited for this, because I have not, like I said, this is the first time I've seen a CO2 ice flaker or ice machine. So I'm excited to see more from you guys.
Yeah, excellent. And Trevor, thank you so much for allowing us to come on. I'm a big fan of the Refrigeration Mentor, and the things you do are awesome. I appreciate it.
Yeah. Thank you so much. Thanks, everyone. Once again, share this on social media, Instagram, LinkedIn, Facebook. Let people know there's companies like Howe, they're making CO2 ice machines. Thanks, everyone. Thank you, Larry.